All right, everybody, welcome back. We'll get started here. Thank you all for, whoa, sorry. Sorry, okay. There we go. Hopefully it's better. Cool, sweet. So yeah, thank you all for coming. I know it's tough on a Monday morning, so I appreciate that you came in person. But this will be a fun lecture. Make it worth your while. So a few announcements. We have, oh, this is actually not updated. Sorry, let me, thought I updated that this morning. Okay, there we go. Okay, there's everything that should be there. So yeah, homework 3 due Wednesday, and then we have regrade request also due Wednesday. So yeah, please make sure that you just check everything thoroughly. Usually there's no mistakes, but sometimes you need to get something regraded. So, and it's a pretty strict deadline because staff needs to keep up with new assignments. So if you don't get it in by Wednesday, we can't do anything about it after that. So please just check out your scores, make sure everything looks good. And then we have our latest lab. And then we also have a project at the end of this week that's going to be released. So this is going to be essentially a longer homework assignment. It's going to take 2 weeks. So you'll have 2 weeks to do it instead of 1 week. There'll also be a checkpoint like halfway through that you have to submit. So like the following Friday, you submit a checkpoint just to make sure you're kind of like making progress and not just doing it all last minute. And we'll have some more details on Ed about the logistics of that. You'll get to work with one person in your lab if you want to. Totally optional, but highly recommended. But it's going to be basically just like a homework assignment. And then just for today, I have my office hours always on Mondays, but I have some stuff that to do in person away from Berkeley. So I'm gonna have to do it over Zoom, roughly the same time, slightly shorter, 4:30 to 6. But the Zoom link is here in the slides, so I'll be on that Zoom. So just see you guys there. Cool. Any questions about logistics stuff? Okay, cool. So we're gonna do a little bit of a recap of histograms, just like finish that up. There was a discussion that we had towards the end of the lecture on Friday about the heights and like the area of a histogram and like what does it mean and all that stuff. So we did some examples on the slides. I'm just going to wrap that up on Python and then we'll move on to some other visualization things. So quick, like main takeaway really for a histogram is that area measures percent. Like that's probably the most important thing when you're looking at a histogram. And so the area of a bar, of any particular bar, if you take it out of the histogram, like one of those rectangles, the area that's there, whatever you end up calculating for that, that's the percent of all of the data that's inside that bin. And then just from kind of geometry, we know that the area of a bar is equal to the height times the width. So we know what the width is typically because we're specifying the bins, or you can kind of see just looking at the x-axis on the bottom, you can see like what the width is of the bin. And then you can figure out kind of what the height is as well based on what you're seeing on the y-axis, how tall is this bin. And so you just know that like the width needs to be, or the area needs to be the width times the height. And so that's just useful, that relationship, because you can kind of like figure out one of those 3 things if you know like 2 of them, just using algebra basically. And so if you want to know like if you're trying to answer a question like what percent of individuals are in this bin, or like how many are in this bin essentially, then you can use area. So if you see a bin that has a bar that's like a lot bigger, just area wise, you know there's more people and more individuals in that bin than like another one. And then if you're comparing the heights of 2 bins, that gives you a sense of how crowded the bin is. So crowdedness, a good way to think about this is like if you took all of your data points and ordered them, so like in an increasing order, then the crowdedness is like, are you seeing a lot of them like together, or are they like really sparse? So if you go to like a particular region of your data set, like between 10 and 12 or something like that, like, am I seeing a lot of individuals there together, or is it really sparse and there's only a few people there? That's basically what height is telling you. So there's like a lot of people in like a very small kind of set of a window, and you just kind of like slide that window over throughout the entire range of your data. And sometimes you'll see like a lot of people in the window, sometimes you won't see that many people. And that's where the bar will be lower for that histogram. So just to kind of wrap up with the example we actually had last week, we'll just take a look at that. So exact same data set, we're just gonna look at it again. So we had these movies, which are like kind of the top movies for each year up until 2017, so like slightly outdated. And then what we wanted to do was we wanted to calculate, for example, the age of the movies. So we had the year of the movies here that was provided to us in this data set. And we said, well, we're actually interested in maybe looking at the age of the movies and seeing like how that might vary or something like that in the data set. And so to calculate the age, what we did is we just took 2023 and then subtract the year column. So this is just a way to manipulate the data. And this is something that's super common. Like the data is not in the format we want. We need to move into a different format. And so once we did that, we added it to the table with a new column called age. So we just took 2023, subtracted the year column. Then we said top movies with column age, and then just passing in ages. So we'll go ahead and do this. And once you do this, the top movies table now has that new column inside it. So if we go here, we see a new age column here. So we basically are just adding this to the table. And then we made some bins for like different ages. And then we said, okay, let's actually bin our data. So to do that, we use the bin function. So we take our table bin with the age column, which is what we're binning on. And then these are the bins that we're using. So we went ahead and did that. And then what we get when you bin is this. So you have the actual bins, which is just kind of arbitrary. It's just kind of what we chose for this particular example. And then you have how many are in each bin. And so you can interpret it by using the number on the right, essentially. So this is basically saying like the 5 to 10 bin has 21 movies in it. The 10 to 15 bin has 17 movies in it, and so on. And then finally, the 65 to 105 bin has 21 movies in it. So this is giving like a count of how many movies are inside each bin that we made. All right. And then once you have the count, that's how you can get to the percentage. So if you want to figure out like what percent of movies are in each of the bins of our histogram, then we basically need to figure out how many movies are there total. That's pretty easy because we can just sum up everything in the second column. That would give us how many movies are there total. So we can just run this. So we have 200 movies total here. And then we can calculate the actual percentage that each bin takes up. So the way we do that is we just say, okay, the 5 to 10 bin has 21 people. So the percent of all the movies that's in that bin is just 21 divided by 200, the total, which is gonna be like roughly 10%. And then similarly for the 10 to 15 bin, the percent of movies that are inside that bin among all the movies is 17 divided by 200, and so on. And so that's the math for how we would calculate percentage once we have the counts. So in general, when you have your data set, you're gonna have the ability to generate these counts using the bin function. And then if you want to take another step further and like figure out what the percentages are, then you just divide the counts by like the total of all the counts. That's pretty much it. And then if we want, we can do that in Python for the entire column. So we can just go here and say bin data.column, give me the counts divided by the total number of movies. Let's multiply it by 100 so we get like a nice percentage. And then we can add that as like a new column as well if we want to. And this is what we get. So we have that 5 to 10 bin had 21 movies. That corresponds to 10.5%, 17 movies, 8.5%, and so on. So now we have all the percentages. And that just gives you a sense of how you can calculate actual percentages. And this now kind of circles back really nicely with the histogram that we made initially. So now I'll just show you both of these together. So this is a histogram that we made using the exact same bins that we have here in this first column. And we see a chart like this. And you can basically use these numbers directly with each of these. So basically it's saying this first bin, this kind of tall one, actually the tallest one, has 10.5% of the data. Then the second one has 8.5%, this one has 20.5%, and so on. And then this last bin at the very end also has 10.5%. So it's kind of interesting. This last bin has the same amount of area actually as this first one, even though it's a lot shorter because it's a lot wider. So it's kind of nice to be able to maybe see all these together here. And so this is kind of the general way that if you wanted to like figure out the percentage, this is how you could do it using Python because you have the counts already. You already have like all your individuals. So you're basically just counting up like how many individuals are in the bin and then dividing by total number of individuals. Now, if you're looking at this without looking at the actual data and you just had the chart, you could also sort of figure out roughly what the percentage must be. So for example, this one here, this is 65 to 105. So that's going to be a width of 40. And the height of this is like maybe 0.25 or almost 0.25. So I'm able to determine that because 0.5 is over here. It's this line. And so this is like about halfway up. So I could say like the height of this is like roughly 1/4, and then the width is 40. So if I multiply that together, I should get like roughly 10% as like how much is in that bin. And then that is what we get here. So we see that 10.5. So I was like pretty close by just estimating that way. And so you could go ahead and like do that same exercise for basically like any of these bins. So for example, if you wanted to do this bin, this is 25 to 40. So that's this bin, 25 to 40. So that's a width of 15, height's like roughly 1.5. So basically it's like 15 times 1.5. That's like roughly how much I should expect to be there. And the actual number is 20.5. So any questions about that and how we like calculate areas? The most important thing is really like how do you calculate areas in a histogram? Yeah. Oh, that's a good question. If the first one and the last one has the same amount of data, why do they look so different? It's really because that's how we chose the bins in this case. So we happen to just choose a really narrow bin here. And so there's just like there's a lot of data in that very narrow set of range. And then in this case, there isn't that much data throughout the like per year, you could say. So it's just distributed. It's like spread across like a wider range, basically. So it's kind of like same amount of data, but one's just like a lot, and then one's like really sparse. Yeah. And that's gonna be super common. That's pretty much always gonna happen. Yeah.
So with this method, with like the state of the data be preserved no matter what size we made our data?
Ooh, that's a good question. So like, does the shape of the data get preserved no matter what bins you use? Well, we can try something else. Let's try actually like another bin. So I'm just gonna make something up here. So the data is from like 5 to 105. So we could do like np.arrange from like 0 to let's do 105. Maybe instead of doing all these arbitrary ones, we could do like increments of 5, for example. So I have not tried this. Let's just see what happens. So looks pretty similar. The shape's like pretty similar. We could try something else. Like we could do 0 to 110 in increments of 10, make them a little bit wider. Also see something similar, though you don't have this like really tall bin on the left now, right? So, but it's still kind of like the similar shape. And then if you wanted to do really extreme, you could go the other direction and say, let's just do bins of 1. So it's like really, really narrow. Then you get something like this. So still looks kind of similar, but you know, it's kind of up to you to decide like which way you want to go about it. Usually you want to use like probably wider bins than just one, because at that point, if you're making it so small, you're just going to have like one thing in each bin, and that's not that interesting. So usually you're trying to tell a story. Maybe there's like some meaningful values here that are interesting. Like maybe something happened like 40 years ago, like the movie industry changed. And so like we care about that number specifically or something, right? So it just depends on the context of the problem. But overall, as you're seeing, like it's going to change a little bit, the shape, but not so drastically. Yeah, it's a really good question though. Question on the Zoom, where did you get the percent per year column? Okay, so when you make a histogram, it's gonna automatically generate the units on the axes. So on the x-axis in the bottom, it's gonna put age, and then we specified what the units are a year, because age is in years. And then for the y-axis, it infers that because the x-axis is year, the y-axis must be percent per year. So I never actually wrote this up, percent per year. The histogram function just determined that for us. And why is that? It's because area is percent. So if this whole thing is in the units of like something percent, and I know that the width is in years, that needs to be multiplied by the height to get to percent, right? So I can just write this out actually. So I know that area is in percent. I know that width is in years. And then I also know that width times height needs to be equal to the area, right? And so basically width is years, height is, I don't know what that needs to be, area is percent. And so just do some algebra there. Basically that means height needs to be percent per year. So that's kind of why it says that. So it looks kind of funny, but Python will automatically generate that for you when you do this hist function. Right, and those units basically just telling you like the crowdedness thing, right? So it's like we had like 2% of the data per year throughout this range, whereas only had like 0.25% of the data per year throughout this range. So just again, giving you a sense of like how sparse or like crowded is the data throughout that range per year. Right, cool. So that's histograms. And yeah, really the most important thing is just areas, be able to calculate areas and be able to compare two different bars. Cool, and so just overall summary of like all the charts you've seen so far. These are the main charts actually we're going to use throughout the semester. We'll do some more interesting things with them, but these are the main ones we're going to learn for this class. So we have our line graph that's mainly used for sequential data. So if usually it's like stuff over time, there could be other situations where you might do sequential data, but basically it's like you're expecting like something to move like up and down as you go from left to right. You're not expecting like this curve to go like back and forth. Like that doesn't really make sense for a line graph. So you should just have data kind of moving in one direction sort of. A scatter plot is more for when you have data that could just be all around. And so there you just plot points. You might have more than one y value for a given x value. So that's where you would use a scatter plot. Both of them are for numerical data, but just depends on how the data is structured. And then when you have categorical variables, then you start using something like a bar chart. And so a bar chart gives you the distribution of a categorical variable, or it could also show you the relationship between a categorical variable and like another numerical variable. Like for example, I could see like all the different unique studios and like what's the average age of a movie in the studio or something like that. So that would be a way to plot like a numerical against a categorical with the bar chart. And then lastly, histogram is just distribution, but a numerical variable rather than categorical. So these are like the 4 different charts. So I figured just to kind of like drill it in a little bit, let's just do one more example with all these charts using our survey that you guys all filled out. So this is the welcome survey. So we'll use this quite a bit. We'll reference it a lot. We're going to reference it again on Wednesday, but I figured I'd just show you like a few more visualizations. So firstly, let's say we wanted to look at the distribution of handedness. So I want to get a sense of like what % of the class is like right-handed versus left-handed versus like ambidextrous. So what's a good visualization that I could use for that? What chart would you want to use to visualize the distribution of handedness? Yeah, bar chart. So the way we do this is, firstly, we need to get the counts of how many people are inside each of the different categories. So like right-handed, left-handed, ambidextrous. Right now, the table is not quite in that format. So we have to use group first. So we can call this handedness, let's say, and we could do survey.group handedness. Sorry, I'll move it up a little bit here. And then this generates a table where we get our counts. So how many are in each one. And so now this is actually in like got a distribution form essentially. So I have the unique values rather than a bunch of different values like repeated. And then I know how many are in each unique value. That's essentially a distribution. And then we can go ahead now and make a bar chart out of this. So I can just take handedness and then do bar H handedness. So any guesses? Oh, sorry, I actually already showed you the data. So actually that's not as interesting. Okay, we'll do another guess for another one. So as you can see, like about 10% of the class is left-handed, slightly less than 10% actually. And then most of the class is right-handed. So this is pretty similar across like most semesters. Maybe we can do this with another one. So let's do another one where it's a little bit more fun to try to guess it beforehand. So let's do sleep position. And we'll do the same thing. So we're going to group sleep position. And then I'm just going to go ahead and do this in one line of code. So group on sleep position, and then take that resulting table, make a bar chart out of it. And same thing, do it with sleep position. So any guesses here? So we have sleep position, which is on your right, on your back, and on your stomach, I guess. So yeah, any thoughts on like what's going to be the most popular way to sleep? What do you think? Side? One of the sides? What about like the back, sleeping on your back? Do you think that's going to be like about a quarter of the class or a lot less? Less? How about stomach? Okay, do you think stomach or back is going to be more? Okay, a couple of people I heard say stomach, but those are probably the people who answered stomach, but let's see. Okay, so side is the most popular, right side slightly more popular, but not that much more, even though like most of the class is right-handed, so that's kind of interesting. And then yeah, the stomach sleepers are really kind of in the minority there. I don't know like the whole science of like which side you're supposed to sleep on, but it's probably good to do like some research on it. But it's also just everybody's just comfortable sleeping like however they want to sleep. So my wife sleeps on her stomach. I don't understand how, but anyways. Okay, so another kind of fun one to look at is extroversion. So for extroversion, sorry, I kind of gave it away. But extroversion is a numerical column. So if you want to visualize the distribution of extroversion, we would need to do that using a histogram rather than a bar chart. And just to remind you, the way extroversion, the way you're answering this, basically if you answered like a 1 or a 2, you're like not that extroverted, you're more introverted. And then if you do like a 9 or a 10, you're like super extroverted. So another question for you, like, do you think the class is gonna be more extroverted or introverted? More introverted? Okay, all right, let's check it out. So we'll do survey, dot histogram, we'll do extroversion. And then for the bins, I'm just gonna go ahead and just do a range from 0 to 11. And we'll just see how that works, because all the responses are between like 0 and 10, or 1 and 10, I think, so. Okay, so actually most of the class is extroverted, which is interesting. So it's like, seems like more than half, maybe like a third or something is like less than 5. So kind of interesting, right? A little bit surprising to see some of these results. Another one we can do is hours of sleep. So for example, we could take hours of sleep, do some similar bins. I'm just going to go ahead and go from like 3 to 13. I don't really know like what hours people are sleeping, but I figured that's going to cover most people. And so this is what we see. So unfortunately, it looks like about a third of the class is like only a third is getting about more than 8 hours, and then like 2/3 is like slightly less, but pretty close. So, doing well, but we'd like to see if we can move this to the side more throughout the semester, maybe. But it's kind of interesting to see. So a fun question here is also, what do you think is the maximum that someone's getting hours of sleep? Any guesses? Because I specifically chose this range, 3 to 13, right? But the max could be outside this range. Like we haven't actually looked at that yet. Any guesses? 14. So in past semesters, it's been usually like 10 or 12. So let's see. Okay. So someone's getting 15. Liar. Yeah, I'm really jealous. That's really impressive. So yeah, so it's kind of cool. So let's actually take a look at doing this again with a wider range of data. So let's actually go from like 0 to 16, just to make sure we include this person, because we actually excluded them. Okay, so interesting. So we did 0 to 16, but we actually don't see anything at 15. Any guesses? Why aren't we seeing anything at 15? Yeah. Yeah, so this is out of 1,800 students, right? And area is percent of the data. So if you have one person out of like 1,800, let's actually do the math on that, right? So like 1 out of 1,800. Okay, so this is like 0.05% of the data. So that percentage is so small that like Python can't even draw it, because it's like less than a pixel basically. Like we just can't draw it. It's so small. So at that point, Python just like, okay, I'm not even going to bother, because like that rounds down to like 0 pixels. And so it's just not able to draw it. Maybe if you had like a 20K monitor or something, you'd be able to see it. So it's just too small. All right, so that can happen. But that's good to understand that, like, okay, even though I'm not seeing anything, there could be data there. And it's really good exercise in general when you're making histograms to like assess like what's the minimum, what's the maximum. So that's just helpful to know. Cool. Okay, let's do one more visualization here. So let's try to visualize the association between extroversion and, well, actually, do you think extroversion could be associated with any of these other columns, just based on like the ones that we asked you about here? Number of textees, maybe, right? If you're more extroverted, maybe you're texting like a lot more people. So we could try to look at what could we use to like visualize that association? What chart would we use for that? A little louder? Scatter plot? Yeah, let's try a scatter plot. So we're gonna do extroversion, number of textees. Let's see if there's any sort of interesting association. So let's try this. So we're gonna do survey.scatter, extroversion. Oh man, really butchered that. Number of textees. Okay, so you see something like this. So we have extroversion scale here. Someone said they'd text 1,000 people. I mean, okay. So I'm gonna try to that number is just like too round, I feel like. Okay, so I'm gonna try to change the range a bit here. So you don't need to know how to do this. I'm gonna change the range on the y-axis from 0 to like 125, just to zoom in a bit, because it's kind of hard to see the way this is. So let's actually just try this. And so this is like a little bit easier to see. So it's kind of cool. You can see like on the left here, we have, it's kind of capping out at around 20. It's still mostly 20 for most people in general, but you do see some of these like outliers, and they tend to happen more on the right side, extroversion. We can't really tell exactly what's going on though, because there's just so many dots. It's like 1,800 points. Like I don't really know like how these are really spread apart. Like it's just, there's a lot of overlaps here. So it's maybe not the best visualization to do. And we could definitely improve on this. And something we're gonna do on Wednesday is, instead of showing you all of these points, we're going to take the average within every single value of extroversion and just plot a single point. So like summarize this entire thing with just one point, which is the average. And then you'll actually notice kind of an interesting pattern. So we'll do that on Wednesday. So there's some limitations of the way you were doing it right now with just this data, but it's kind of cool. You can still see some sort of interesting maybe association here. And so scatter plot works for that. Cool. How about a line graph? Could we use a line graph for anything here, do you think? Any of these columns? Yes, no? Thoughts? Seems hard, right? So usually you want something sequential. Does anything look sequential in any of these columns? Let's start with that maybe. Does something look like if I was visualizing it from like left to right, it might make some sense as like a sequence of like a progression or something like that. Year, right? Year looks like that. So year, I have first year, second year, third year. We even have like a few graduate students. So you can actually see maybe there's like a progression there. Like maybe we could look at like year and like hours of sleep. Like how does that change? That might be kind of fun to see, right? So unfortunately, we can't do that quite yet because it's in a string format. So if I try to go and do like a line plot right now, it's not going to work because it's going to say like year is a string and that's not allowed. It needs to be a number. So if we could convert this to a number, like I could convert first year to 1 and like second year to 2 and so on, then we could do that. But we can't quite do it in the format it's in right now. And we need a way to convert it. So what we're going to talk about for the rest of today's lecture is just like how do we actually convert stuff into other formats? How could we maybe write some code to help us do that in a really efficient way, rather than having to do this like one by one and like replace it with like a new column. So that's kind of what we're going to get to. And then hopefully maybe if we have time on the later lectures on Wednesday or Friday, we'll actually do it and you can actually see what this looks like if you plot like year against hours of sleep. But this is just a common thing that will happen. Like sometimes your data is just formatted like not in the right way for the visualization you want to make, but you could certainly translate it. And we'll talk a little bit more about that. Cool. So that's the main kind of overview there on charts. We have some time. We can do a quick discussion question. We'll just maybe spend a minute on this. So suppose you have this data about daily temperatures and it looks like this. So which type of chart would show the answer to each of the following questions? So first question is, are there more cloudy than sunny days? Then we have what percentage of days have a high of at least 72%? And then the last question is, do days with hotter highs tend to have hotter lows? So let's maybe take a minute to discuss with the person next to you, and then we'll go over the answers. Okay, let's try to go over this. It's okay if you didn't get through all of them. So are there more cloudy than sunny days? What's the visualization for that? Yeah, or we usually call it bar chart, but I guess bar plot's fine too. But yeah, bar chart. So bar H is how we would do it. So sunny, cloudy, look over here, that's strings. It's going to be categorical. And if you're trying to figure out more cloudy than sunny, it's kind of like, do we have a higher percentage of cloudy than sunny? Basically talking about distribution. And how do we create categorical distribution? It's with the bar chart. So that's that. How about this one? Percentage of days that have a high of at least 72%. Yeah. Yeah, histogram. So for this one, we're looking at just highs. So we have like all these highs here. This is just the highs column. And we want to know like what percentage of that column has a high at least 72%. So we could just do that in a histogram. And this is a situation where maybe you'd want to just like make your bins like 0 to 72 to like 150 or something, because you just care about like what percentage is like less than or more than 72. Or maybe you can make the bins like equally spaced actually, so they're equal widths. Then it's like really easy, just compare the heights. So that's a situation where you can maybe decide how you want to do the bins there to answer that question. And then how about the last one? So do days with hotter highs tend to have hotter lows? Any guesses? Yeah. Yeah, scatter plot. So highs is a numerical column, lows also numerical. And so a scatter plot would make a lot of sense here. You could maybe think like a line plot could make sense here, but I think the main issue with doing a line plot is like you're going to have potentially multiple values of like highs for each value of a low. And so that line's not really going to make sense. In general, for this type of data set, the main place where you would use a line plot is like if you had day on the x-axis. So day is like going 1, 2, 3, 4, 5, and then you have like how is the temperature changing. So that's one where you could use a line plot. Cool. All right. So just quick recap. Why are we doing all this, and why are we doing what we're going to do next? So charts in general can convey a lot of information in a really interpretable manner, and in general, people are just really good at noticing patterns when it's visualized. So, if you present somebody with just like a table of data, that's like sometimes hard to parse, but visualizations, people are just naturally a little bit easier to notice patterns. And so far we've covered essentially how to generate and correctly interpret these visualizations. We also know a little bit now how we can isolate like the part of the table that we want to visualize, like take a specific column, maybe even convert it into a different value if it's numerical. And so what we're gonna do next is manipulate the data that you have into data that you want to visualize. So for example, like changing year from a string to a text, or sorry, from string to a number, how could we do that? And then just kind of completing the tool set of table operations. So that will be like today and the rest of this week. So we're just gonna wrap up sort of like the main Python fundamentals that you need for like manipulating tables. And then we'll be able to make all kinds of visualizations by the end of this week. And it'll kind of get us to a really good spot. Cool. So the first step to manipulating data for us is gonna be defining functions. So you've already been using functions like max and min and absolute value, but you can actually make your own functions to do whatever you want to do arbitrarily. So we're going to do that right now. And this is going to be very useful because every data set's different and you might have some unique needs. So you might need to make your own function. So we can call these like user defined functions. So, you have like functions built into Python. You have some functions that we got because we imported the data science library. And then we'll also have our own functions that we need to write because it's not covered in all those other things. And so here's how we define a function. So in Python, this is how you'd write it. So you always start with def, and then you put the name of your function. This name can be basically whatever you want. You should make it something that has some context and like actually explains what you're doing. So in this particular case, this is a function that takes in like an array of values, like a column of data, and it returns the spread of those values. So like the maximum value minus the minimum value. That's what this particular function does. And so spread seems like a good name for that. So you'll kind of put the name of the function, and then in parentheses, you'll put in the arguments to the function. And each argument that you have has to have a name. And so you can choose this name as well. So we chose values in this particular case. You could choose whatever makes sense for you. And in this case, it's just one argument. It's just one name, values. If you have more, you can just separate them with commas. And what's going to happen is, regardless of what your function is doing down below, we'll get to that in a second, just paying attention to this line. If you go and later on in your notebook, try to call this function, so you say like spread and then pass in like some array, what's going to happen is this function is going to behind the scenes assign that argument, whatever you pass, like the array, to this name values, and then like use that throughout the course of the function. And then maybe it'll return something back out to you. So we'll explain that a little bit more in a second, but that's basically what this is going to do. And then finally, you have what does this function actually do? That's everything you write below. So after the first line of defining it, you write what does the function actually do? And so in this particular case, this function is going to return the maximum of the values minus the minimum of the values. And return basically means like kind of print it out in the next below, like outside of your cell in the output. That's what it's doing there. And so it's really important also to have this indentation. So whatever you indent, that's going to be part of the function itself. And so we'll see some more examples of this, but this is just like the general skeleton. And so we have like the name of our function, the argument names. In this case, is just one name, one argument. And then we have the body. We call this the body of the function, right? And your body can be as many lines as you want. In this case, the body is really simple. It's just one line of code, but sometimes it could be more. And we'll see examples of that right now. And then usually the last line of your function, at least for this class, is going to be a return expression. So you're going to return something out of this function, because usually you're doing the function, running the function to like generate some result. And so that's how you return the value. All right. So see some examples of this right now, and this will make a little bit more sense. So let's start out by making a function that will take some numerical value and then triple it. So for example, like I want to make a function like this, triple x, and if I just pass in some number x, it should return 3 times x. So how could I do that in Python? Well, we can just follow steps. So first I have to start with def. Then I have to put the name of my function. So in this case, I'm going to call it triple, but you could call it like whatever you want. And then we have our argument that needs to go in. I need some number to be passed into this function. So we can just call this x. And then we have a colon at the end here. And then we have the actual set of body of this function. And so if once I type this out and I hit return, it automatically indents for me. Python knows that I'm like going to start writing a function here. So it indents for me. So it's very important that you do that. And this one's pretty simple. We just want to return 3 times a number. So I can just write this as return, 3 times x. And I go ahead and run this. And there's no output here, actually, once I run this. But it's really important that I run it, because once I run it, Python knows like, okay, this function is now defined. That's why you run it. And then we can go ahead and call this function. So I can say, okay, let's do triple of 3. And then what's going to happen when I call this is 3 is going to get stuck into here. It's going to get assigned to x. And then the function will run assuming that x equals 3 for this particular case. And so we go ahead and run it and we get 9. So it goes through like all the math for us, basically. And you can also pass in a name. So for example, I make a name like num equals 4. And then I can say, give me the triple of num. I can do that as well. That's fine. So this, whatever name you have here, it's just kind of like an internal thing for the function. Like the function itself, when it's running, it's like, okay, whatever value you give me, I'm going to call that x. But you can give whatever value you want to it. And then it will handle the rest for you, basically. All right. And then you can put like more interesting expressions. I mean, we've already done this at this point with other functions, but you can do this with your own functions. So I could say like do num times 5, and then take that entire result and triple it. That's how I would run that line of code. In this case, we get 60. All right, so that's how we can kind of run that function. And then one interesting thing about functions in Python is that they don't really care like what type it is. So you can actually pass in whatever type you want. It may not always work. You kind of have to know the rules of Python to know if it's actually going to work. But in general, you can actually pass in whatever you want. So for example, this triple function, I could, instead of passing it a number, I could actually pass it a string. And if I do this, it actually works, because in this case, we know that I can take a string and multiply it by an integer. Like Python, that's okay in the rules of Python. So passing it in here actually works fine, and it works out. We could similarly do the same thing with like an array. So I could just make up some array, like arrange from like 0 to 5, and then pass that in, and then the triple function works on that as well. So just to show you what the original value would be, it's 0, 1, 2, 3, 4. So passing that into triple basically just triples each of the values. And we know that's going to work because we know we can multiply arrays by numbers, right? The situation where this might not work is if we pass in like an entire table. If I put in a table, I don't think you can do like table times 3. And so in that case, you might get an error. We could actually try it. I'm not sure if that's going to happen, but I think it should happen. So let's take like survey, for example, and then let's try to just like triple the survey table. Okay, so here we get an error. So it says like unsupported. You can't do like multiply an integer by a table, basically. So you can kind of pass whatever you want into the function. It may or may not work, depends on how you wrote it. In this case, you can pass most things because it's just multiplying by 3. So any question about that so far? Yeah. Triple X, you mean like call the function twice in one line? Yeah, for sure. You can definitely do that. So you can like do, triple 3 plus like triple times something else. So you can definitely like call them together. I can like multiply these together. That's fine. So I can like combine them together. And then you can also reference this function inside something else. So, I can make like another function like triple twice or something. Let me call it like this. And then what I could do is I could say, okay, return triple of x and then like time plus triple of x or something like that. So you could do whatever you want there. So you can definitely like reference other functions within your function as well. That's fine. But just make sure when you run something like this, you've already run this first. So you know like something's defined. But, yeah. Any other questions about functions? Okay. All right, so I think we will maybe skip the discussion question. Well, actually, okay. Well, we just want to discuss it like individually. But anyway, so we have this. Here's an example function. So it says def f of s, and then what it does is return np.round s divided by sum of s times 100, comma 2. So question basically here is like, what does this function do? What kind of input does it take? What output will it give? What's a reasonable name for this function? All right. So we're a little bit short on time, so I just want to at least just explain what this is. So essentially what this is doing, if you just try to read what's happening here, that will give you a little bit of a hint. So it's saying like, okay, we're taking s, which is the argument. So I don't really know what that is. Maybe it could be a number, maybe it could be something else. And I'm dividing by the sum of s. So right there, when I'm taking s and dividing by the sum of s, you should be sort of thinking like, okay, what types would it make sense to do that? Like, would I take the sum of the number 2? That probably doesn't make sense. I probably wouldn't take the sum of like a string, but I maybe would take the sum of like an array of values. That's something that I could take a sum of. And so maybe the input for this is like an array of values. So let's say I had an array of like numbers. And so I did S divided by the sum of S. That sounds a little bit like what we did when we were doing the histogram calculation at the beginning of the lecture, right? We took each individual value and divided by its sum. And what we were doing there was calculating a percentage. And so maybe this is determining like what percent of each individual value is inside that. And another way you can actually try this out is like just test it. So we could just make an array like, let's just do a range of values actually. So we can do a range of values, and then we can actually just try this out. So we could say S divided by sum of S. What does that give us? Okay, so basically what happened is it took these numbers 0, 1, 2, 3 up to 9, and then it converted them into percentages. So we have like, the number 8 is like 17% of like all the numbers. And just show it here for you too. So that's kind of what's happening here. And then finally multiplied by 100 because we wanted to make it look like something that's more familiar. So rather than seeing 0.17, I'd like to see like 17.7%. And then finally, once you have that result, what it's doing is it's saying, let's round that whole thing to 2 decimal places. And so I can go ahead and write this as well if you want to just see what it's doing. And then it's just rounding the result to 2 decimal places. So basically now what we can say is, okay, this is a function that will take in an array of numerical values. It'll convert each individual value into the percentage that it takes up of all the numbers in the array and rounds that to 2 decimal places. So that's basically what it's doing. And so like a reasonable name for this function, instead of just calling it f, maybe it could be like percent of total. So like if I had to write this whole function from scratch, I could say like, maybe I should call this percent of total. That's maybe like a more interesting name. And then maybe instead of just calling the input s, I could even just call it like values or something. So I understand it's an array of values. And then I basically just want to return this math here, but with values. And so that's like one way to define this. And then it's also good be a good habit to like put a comment here too. So I could say like this function takes in an array of values and returns the percent of the total. And then you might want to put this on multiple lines, but this kind of lets you explain what the function's doing. And so that's one way to just kind of go through the exercise of like, what is this function doing? What should the name be? And that's just helpful because in general, you're going to have to do this. Like you're going to notice that you're writing some code and you're noticing you have to write it again and again and again. And you're like, oh, it'd be really nice if I could just put that into a function and just call that function rather than having to like rewrite all that code. Because this is actually like kind of a lot. And if I keep writing this again and again in my notebook, I might make some mistakes on it. So it's kind of helpful to maybe make it into a function. So that's one way that we can do that. One other thing to cover about functions is that you can have them pass in multiple arguments. So we've seen a couple examples of functions that we've used already that do this, but an example of where you might need to do this is, for example, let's say that you have a right triangle and you know like the width and the height of it, and so I need to know like what's the length of the hypotenuse. So you could write a function that helps you do this. So for example, we could say, let's call this function hypotenuse, and then it's going to take in 2 arguments, x and y. So here I have x comma y. So these are basically like the 2 numbers for like the height and the width of this rectangle. And then we could say, I'm going to take the hypotenuse squared is going to be x raised to the 2nd power, whoops, plus y raised to the 2nd power. So I'm just doing this like first step here. So I'm just writing that here in code basically. Once I have it squared, I need to take the square root. So the hypotenuse itself is actually just going to be the square root of this thing. So NP, we'll do hypotenuse squared raised to the 0.5 power, which takes its square root. And then finally, we just return the hypotenuse. And so this is one way to write this function in Python. And we can go ahead and try this out. So we could try like some values of some like common triangles. So we could do like 3 and 4, and then we get the hypotenuse is 5. I could change this up a bit, 3 and 5, I get 5.83, and so on. So that's like a way to write a function with 2 arguments. And what Python's going to do is it's going to treat this in the exact same order that you wrote it. So it's going to say, okay, x is going to be 3, y is going to be 5 when the function runs. And then it's going to carry out like whatever it needs to do. All right. Cool. Any questions about that example? All right. So just a few more things to cover. You can combine types together into a function. So let's make a simpler example where let's say I have like the year that someone was born and I want to convert that to their age. An easy way to do this is to just return 2023 minus the year they were born. So for example, Joe Biden was born in 1942, so I can just pass that in, and it gives me his year, his age. Now you could do something more fancy, which is you could take a name and a year and convert that into a sentence. So here I'm going to make a function called name and age, and in this case, I'm going to take in the name of this person, which is a string, and the year, which is a number, combine that together into like a fancy like sentence that says like this person is this many years old. So in this case, for example, I'm just going to call this function name and age. And what I could do is I could say return name plus the string is with some spaces around it, plus convert this year into an age and then convert it into a string and then years old. And then we can go ahead and like try this out. So let's say I could say, let's call name and age on an example like Joe and year 1942. So I have like basically his name and the year he was born, and then it returns this into a nice string altogether. So this is a way to combine two different types, right? So we had an integer here, we had a string here. The main thing was we converted the integer into a string so they could all be kind of like put together. And then we were able to make this like nice looking sentence here. So that could be something kind of helpful to do. Cool. Any questions about that example? Yeah. Yeah, that's a good question. So up here, when you define this age, we had 2023, and that's like the current year, right? But like maybe I'm doing this notebook like next year, and I want to change this number. So you could actually make this a variable that's just defined outside the function. That's like one kind of cool thing about Python. So you could say like current year equals 2023, and just write that at the top of your notebook and like do a bunch of stuff with that. And then you could even like pass this in here. Whoops. And so we can go ahead and like it still runs fine. So it knows to use that current year because it was defined up above. So this could be helpful because like you might put this at the very top of your notebook and then do a bunch of stuff, use it in a bunch of functions in a bunch of different places. But then in the next year, all you have to do is just go up to the top and like change that to 2024, which is probably something that I should have done with this notebook. But very helpful exercise. Cool. So this is a function that combines two things. Last thing to cover is it can be helpful sometimes to be able to run a function over an entire column, rather than just one value at a time. And a situation that you might want to do this is like our original example from the welcome survey. We want to convert all of those first year, second year, all of that into numbers. Rather than having to call this function one by one, we can actually apply this function to the entire column. So I'm just going to show you really quickly how we can do that. So I'm running out of time here, sorry. So I'm just going to copy this over. Okay, so let's say we have a table like this. So I have like my staff. It has two columns, so it has like the name of the people, so I'm just going to call that person, and then the year they were born. And so I go ahead and run this. Here's my staff table. And so one way that I could figure out the age of each person is I could run one by one the age and year function, and it just takes a lot more lines of code. So like this is one way I could do it. I could say make an array that has like the age of the first person in the table, then then add the age of the second person in the table, then add the third person, and keep going. And it just takes like a long time, but that's one way you could do it. But another way you can do it is using the apply function. So I'll show this very quickly to you here. So you could do staff.apply, slightly different way of writing this. I could pass in the function age, specify what column I want to run it on, birth year, and it actually does the exact same thing as these 4 lines of code. So I get the same exact result. So rather than having to like go one by one and run this function on each individual column, or each individual row, I can actually just run it on the entire table, specify what column I want to run it on. And then we could do the same thing with the other function, which is a little bit fancier, name and age. And in this case, you just have to specify the 2 columns that you want to run this on. So the first column is their name, in this case, person. Second column is birth year. So I go ahead and run this, and then it actually runs on all these. Okay, so this is how we can actually apply a function, a little bit more complicated function, to the entire table. All right, we'll stop there and wrap this up on Wednesday. Cool.